All right. Last time on MasterWire, I showed you how to make a basic movement component, a basic movement function inside the flight component, and we set it up with up, down, and the IA move. But now we're going to need some lateral torque to make sure that we can stay balanced. So to do that, the very next function that we're going to need is going to be called lateral damp. Inside, we're going to use the same method. So we're going to need a is simulating physics. So the input for this is going to be a primitive component. Let's just call it target again. Search for a primitive component. Let's get an object reference of that. I got the wrong one. Primitive component, object reference. Let's check if it is simulating physics. Get a branch. So if it is simulating physics, then it'll run the rest of this. And from this same target, we're gonna wanna get the physics linear velocity. If we were doing dampening for the torque, we would want to get the angular velocity instead. But let's get the physics linear velocity. So with this, this is going to be a pretty advanced function, because with this torque, or with this dampening that we're doing for the linear velocity, I want to have an arrow power for it as well, meaning how much can it drive forward despite its sideways drift. So it's going to cancel out the sideways drift in order to force itself to go in the forward direction of whatever direction you input. What we'll do is pull out from here and get the vector length. And another variable that we're going to need here is the desired forward, so we can just pull that in, get desired forward. From the vector length, we can check if it's greater than 0. So just to be sure that we're actually needing to use this. And let's get a branch. This way we're not using the tick so wastefully. And the final is going to be an add force, so we might as well put that now. Let's turn off the context sensitive so we can get the add force from the radial components, physics components. And the target, of course, as always, is going to be the target. I'm still using the same node here, just so everything's clean. All right, so let's go ahead and make the rest of this. After we add the force, we're going to need the actual equation to make this force input here. All right, let's go ahead and make this as advanced as possible. What we're going to do is add a few inputs here. So let's call it arrow power. Let's make this a float. And soft brake. So this is like the passive brake. Might as well call it passive brake power. Last one, brake power. So your manual brake power, basically. We can call it that too. Manual brake power, perfect. Then probably a trigger saying that we're turning on the brake. And probably a trigger for decoupled mode as well. These are going to be booleans. So as always, we probably need to get the mass. So let's just use the target here. Get mass, multiply. Mass is going to be multiplied about 3 times for our 3 different methods, because we have arrow power, passive brake, and manual brake power separately. So let's make our arrow vector first here. We can use the desired forward and the get physics linear velocity. What we'll use, might as well pull a node from here. We can use a node called project vector onto vector. The target vector is going to be our desired forward from earlier. That's from our function that we made here inside of compute lateral, where we found our desired forward by doing this multiplication. So if you missed that one, go back to the first video. I'll show you how to do that. Once we have this projected, we can actually subtract it from itself. So subtract, I'm pulling the get physics linear velocity value and subtract that. Subtract the project vector onto vector from it. Let's get a select vector. Where the B is going to be the raw input from this. Cool. And I'm just doing some organizing here, getting everything a little bit more clean. Now we should probably normalize this value as well. Normalizing the same get physics linear velocity. And let's get the dot product of the desired forward versus the normalization of the physics linear velocity. And we're going to check if that's greater than or equal to. Make sure it's greater than or equal to 0. And that's going to give us our condition to pick A. So all this is still happening on the same tick, just to keep in mind. We can stretch these nodes out a bit, just give us a little bit more room. So this is going to be multiplied by the get mass in order to give us our add force. But we're going to use a couple of select vectors as well, because we need to solve for all of our other conditions too for these other 3. So if we were to just connect this directly, there wouldn't be a way to connect the other ones too. We need to select back and forth between them. So let's use this, and then into another select vector, and finally into the force. So now we can multiply this by the arrow power. Let's get the arrow power. Let's get the arrow power from the input back here and drag it all the way up here. And then we might want to add the select vector last to this multiplication. So it's green, green, and yellow. Good. So this is going to be for our arrow power, this first one here. The second one can be for our passive brake power. We can just go ahead and plug that into the multiplication. Let's use the manual brake power for the last multiplication here. Then use this. Good. And those are all of our multiplications that we need. Let's just go ahead and plug in this second multiplication into the select vector, the third into the select vector B as well. And let's get these conditions solved. So to pick A for the first one, what we want is a vector length is equal to 0. So let's get this desired forward and do it with this. Vector length equals 0. Let's say if it's not Boolean, I could have just said not equals. Do one of these. Not equal to 0. That's perfect. Pick A. Then for the second one, that's going to be our brake input actually. From way back here, we can go ahead and plug that in. But we also want the not Boolean for this probably. Just to reverse it. All right, cool. So we have all those conditions. It's still probably not ready though. What I want to do as well is mess around with that brake input for our decoupled mode. Let's organize this first before we start to get technical. I want to multiply these by a negative value. And specifically the soft brake power. This is how we're going to switch back and forth our decoupled mode. Soft brake means it just, or the passive brake means it's passive all the time. So let's do a select float, and let's have it in the B value actually, and then decouple. Decouple is going to be how we pick A. And this is going to give us this value here. Now let's multiply everything by -1. I'm just going to put these nodes just to organize things. All right, perfect. Now things should be done. So this is how you create a lateral dampening system. And it's a pretty advanced one. If you got all this exactly the same way, you'll be able to use the brake when you want manually if you set that up as an input. And let me just switch these to organize it a bit. Now if we go outside of the function, we can just go ahead and add the lateral damp here. I mean, what we can do is compute it directly after our compute lateral and put a branch here. We're going to have a tick for our custom event here. Add custom event. Let's call this damp tick. Let's give another branch for this. False. So the idea is it's going to tick whenever I'm using move. It's going to tick for the lateral dampening. It's going to make sure that it's on. Or it'll also tick for the dampening, but I want some conditions so that it's not always doing both. So best thing to do is probably make a vector. And I could probably recombine these. Now that I have this vector made here. But what I also want is a vector length. Let's just type in length. Context sensitive, it wasn't on. All right, so vector length greater than 0. If it's greater than 0, meaning I'm using the move up and down, then it's not going to allow us to use the damp tick. If that's true, it's going to do nothing. And then vice versa for the branch going from the compute lateral, it'll check the same thing, but this one's set to true. So that's a clean way of making sure that it continues to tick only when it needs to. But all right, what you have here is lateral dampening. Let's set the arrow power to like 4, passive brake to maybe 5, manual brake power to 5. We have to set up the target. So let's get the same thing, capsule component, set it as the target. There was only one thing I was missing, and that's the fact that damp tick doesn't have any connected, doesn't have a connected tick. I don't know why I missed this. So event tick, you want to plug it into your damp tick. You want to call that a custom event. And now everything works. So we can turn off decouple. And now it has perfect lateral dampening. If I was to check decouple, let's see what happens. Then I have like zero gravity type movement where it continuously goes in whatever direction you want. But if I turn decouple off, it'll stop the moment you stop. It's cool because it lets you change the power of decoupled mode. So your passive brake, or coupled mode if you want to call it that. Your passive brake, let's set it to 2. You get a lot more of a smoother slowdown, as you can see. All the way down to 0, and once it hits 0, it should just turn off. And arrow power can get a little crazy. So let's say I set the arrow power to 10, and I set the movement power to another 0, make it insane speeds. It can handle it. Check this out. Well, I don't want to hit the ground and start spinning out really fast. But check this out. I can go left and right, switch directions instantly. I could even have more speed than this. Let's add another 0. Yeah, check it out. Lets you go in circles. You can remove all issues of having a lateral drift. On your way to having a pro AAA quality flight component that you can use for all your projects and drop into your third-person character without having to change any of these values here. So we're going to do some more fancy stuff with it, make it so that it's activated actually, and it can turn on and off to simulate physics. Let me show you something cool as well. So if I go to the capsule component and find simulate physics and turn it off, what should happen is we should have basic control over the character again without having any issues. So this is the only thing that determines whether or not our logic is working inside of the BPC flight component. But all right, thanks for checking in. Thanks for taking a look at the tutorial. I hope you liked it. If you have any suggestions for the next one or anything else you want to see, please leave a comment or like. But all right, until the next one, thanks again. See you next time.